Hello folks, welcome to session 10 of Data Analytics with Python. I am pleased to guide you through today's session as we dive deeper into the world of data analytics. In this session, we will explore the analytical approaches necessary to effectively monitor progress and make data-driven decisions, to adjust policies aimed at achieving fertility targets. Whether you are a policymaker, data analyst, or a researcher, this session is designed to provide you with valuable insights to assess and track progress toward this important demographic goal. I am BONUS Kagarama, your facilitator, joining you from the stunning land of 1,000 hills. Analyzing the target of achieving the 90% below threshold value, which is between 2 and 3 children per woman. What does this title say? It implies that the policy sets a target for the average number of children per woman not to exceed 2.5 and ensures that at least 90% of children should fall below this threshold, 2.5, to meet the goal. This is the implication of that title. Now, you as a data analyst, which analytical approach can you derive from this target to inform the policy? As a data analyst, here are 3 complementary analytical approaches to be used to inform and guide the policy based on the stated target. The first approach is selecting the variables from the data frame that are aligned to the set policy for analysis. 2 fertility variables will be used. These are age at first cohabitation and the number of living children. Age at first cohabitation is the age at which a woman starts living together with a partner as a long-time relationship. Depending on the choice of a data analyst, any variables can be used as long as they are aligned to the topic and objectives of the study. The second approach is using regression method to measure the correlation between the 2 fertility variables, age at first cohabitation as the independent variable and the number of living children as a dependent variable. The third approach is developing an algorithm for the target value, and it is a target line, regression line, and setting percentages of children below and above the threshold value. Therefore, the approaches are not limited to these outlined here. Depending on the choice of a data analyst, there are other analytical approaches that can be employed to inform this kind of policy. Let's enjoy a short break and then get back to the analytical part. We are now at this user interface. For newcomers, I mean those who don't know how to get here, just visit my tutorial, session 6. It shows you how to open the Jupyter notebook and get to this user interface. Then rename your tutorial. Click here. My tutorial is session 10, data analysis. This is the cell, or you can call it a chunk, where we write codes or commands and texts. You can increase the number of chunks or decrease, delete. The work you are going to do should be having the title. Policy evaluation metrics, analyzing the target of achieving the 90% below threshold value, 2.5 children. Then, import the most common and frequently used libraries. Import pandas as PD, import numpy as np, import matplotlib.pyplot as plot, then import cbon as SNS. Then run. Valid syntax, import numpy as np. This is a what? Error. Okay. Run. Other libraries can be installed or imported on the way when they get needed as we perform data analysis. Then import the data frame. Equal, bring your pandas library.read data, then go to your folder. My folder is named session 10. Open it. Data trend, another folder with the data frames. Open it. So this is the DHS several data frames. Depending on your need, you can use any data frame here. But my data frame of interest is KR, RW, KR. This is Kids dataset. Right-click on it, go to Properties, copy the location, then go back and copy the data frame. The extension is capital DTL. .dtl. Double backslashes. And then execute. So let us copy this data frame to new data frame. df1 equal df.copy. Then execute the new data frame, df1.head. We are now going to use the new data frame to avoid the amendment of the original data frame. Check the size of your data frame. Run. 7,856 rows and 1,078 columns or variables. As you can see here, we have got limited variables or columns, meaning that all the columns are not displayed here. What can we do? We import the library that allows all the columns to be displayed. Go back. pd.set underscore option display dot maximum columns, then none. Run. Access our data frames. Now you can see all columns can appear here. Which variables are you going to check? We are going to work on age at first cohabitation and the number of living children. Age at first cohabitation variable name is V511. And the number of living children variable name is V218. So from this entire data frame, we are going to select only age at first cohabitation and the number of living children. df1 equal df1, select two variables, v511 and v218, age at first cohabitation and the number of living children. Then execute the new data frame for only selected variables. Age at first cohabitation and the number of living children. Now, let us check if these two variables experience missing values. Print, open and close the bracket, then copy the above command. Yeah, this one. That's it here. Dot is now. Dot sum. Then run. Age at first cohabitation has got 693 missing values. Number of living children has no any missing values. Now, let us treat the missing values. df1 equal df1 dot drop na. Drop na means drop the missing value. Subset equal age at first cohabitation and the number of living children. Run. Name drop na is not defined. This is df1 dot. Okay. Copy the above command and re-examine the missing values. Run. So you can see here, age at first cohabitation, no missing values. Number of living children, no missing values as it appeared before. Okay, all the missing values have been treated. We are going to examine if our quantitative variables, age at first cohabitation and the number of living children, are float or numeric type. Bring your data frame and your variable age at first cohabitation, V511. Bring again the data frame and the second variable, number of living children, V218. Open the bracket, close the bracket, then run. You can see V511, age at first cohabitation, is float. This is fine. Then, number of living children is integer type. We should clean this from integer type to float type. Okay. Bring your data frame and your variable, number of living children, equal, copy this again, dot as type, plot, then run. Copy again the above command, re-examine the above command, run, and see number of living children change from integer type to float type. Okay. Age at first cohabitation is float as usual. So let us check the coefficient of correlation between age at first cohabitation as the independent variable and the number of living children as a dependent variable. NumPy.correlation coefficient being the data frame and your variable, age at first cohabitation, V511, in the data frame again and your variable, number of living children, V218, 01. The coefficient of correlation is between 0 and 1. Run. Then print coefficient of correlation create the dictionary, then bring the new created variable for correlation. Coefficient of correlation is computed in 2 decimal places. Okay, minus 2.25. Weak negative correlation between age at first cohabitation and the number of living children. Let us define variables for x and y. X as the independent variable and y as the dependent variable. Age at first cohabitation independent variable. Of living children, dependent variable. Then print x.shape, y.shape. Y is not defined. This is a capital Y, it should be in a small letter. Okay. Next, to know the ranges of x and y, let us find the minimum and the maximum values of these two variables, v511 and v218. These signs are Docker strings. It is another way of writing the text with at least one line. So below the text, you write the command. Bring your data frame and your variable v511 to describe, comma, bring your data frame again and your variable v218 describe, open the bracket here and close the bracket. Run. v511, age at first computation. It means that women began to cohabitate with a partner at the youngest age of 12, and some other women started cohabitation at the oldest age of 39. v211, number of living children. It means that some women between the age of 12 and 39 do not have any children, and some have got the maximum number of 11 children. So, we are going to develop an algorithm to create our model. As we are going to work on dependent variable and independent variable, and as both are quantitative variables, we first import the library for linear regression. From skipper.stars, import linear regression. Run. Now we are going to fix the data with a CD value that produces the same correlation coefficient as the one computed above. The best choice of the CD value that yields the computed correlation coefficient is done after development of an algorithm. So let us set our provision CD value, of which we can amend later after completing our algorithm. NumPy.random dot seed. It can be any value, but let us currently make it 42. Run. So we are going to create an array X with the edge values from 12 to 38 with a step size of 2. Why from 12 to 38? Because the minimum value for edge at first computation is 12 and the maximum value is 39. It means that with the step size of 2, 39 is exclusive. X equal numpy.arrange (12, 39) with the increment of 2. What does it mean here? The code X equal to numpy.arrange 12, 39, 2 with the values starting from 12 to 38, 39 exclusive, as each successive value increases by 2. So let us print our X array and see. Run. From 12 to 38 with the increment of 2. 12, 14, 16, 18, and so on. Now, omit this. It was just to see how this array looks like. We are going to generate an array Y of random integers, where the number of elements in array Y equal the length of array X. Below this text, you write the command Y equal numpy.random rand 0, 12 size equal len X. This generates random integers between 0 inclusive and 12 exclusive with a total number of random integers equal to the length of an array X. Why 0 and 12? Because the minimum value for number of living children is 0. The maximum is 12. Now here 12 is exclusive. So let us print our iteration Y and C. These are random integers. Okay. If we deactivate the seed value here and we run for the second time, you can see the integers keep on changing. Run again, the integers change. Why? Because these are random numbers. This is the essence of fixing the seed value, because it ensures the same data is generated every time the code runs. Deactivate our seed value again, run. You can see our original random numbers. Run again. It doesn't change. So, because we fixed the seed value. Omit this. So, omit this print. Run. Then define a target value. target value equal to 0.5. Run. Determining regression line. The regression line has got a slope, intercept, and the error value. Error value is coefficient of correlation equal linear regression of xy. Run. Calculating regression values. Regression line equal slope times x plus intercept. Run. Let's calculate percentages below and above the target value. Percentages above target equal y is greater than the target value dot sum over len y times 100. Len y is the total count of children. This is percentage above target. Percentage below target. Copy the same command down. This is below. Y less than target value. Percentage below. Then create a data frame. df1 equal, bring your pandas library dot data frame, create the dictionary where age at first cohabitation is the key and x is the associated value. Then number of living children is the key and y is the associated value. In other words, x and y are iterations or arrays containing data for age at first cohabitation and the number of living children. Run. Let us plot a bar chart. Plot.figure let us give our figure the size of 13 as the width and 4 as the height. Plot, then plot.bar, bring your data frame and the age at first cohabitation. Bring the data frame again and the variable number of living children. Add the color for the bar chart. Make it blue. Also add the edge color as black. Then label is the number of children. Run. undetermined string literal detected at line 34. Okay. Edge color equal black. Okay. Collect it like that. Run. Another error message. Name figure size is not defined. In bracket, figure size equal 13.4. Run. So the figure contains a blue color. Let us change the color. Make it sky blue. Run. Okay. This is edge color, black. And then the bars are colored as sky blue. Then plot the target line. Bring plot as the library for matplotlib dot axh line. Bring your new created variable target value. Add a color for your target line. Make it red. Add another argument for line style equal dashes line width equal to. Add another argument for labeling the target value as target. Label equal f target, where my target value is rounded to 2 decimal places. Run. Target value is not defined. This is a small letter, not capital T. Run. Let us change the color of this target line to green. Color, make it green. Run. Okay. Let's take a short break and resume in a little while. We have plotted the target line. Let us also plot the regression line. In your library PLT for plotting, dot plot x regression line. Copy this. Add the color as red. Then add the size of the regression line. Line width equal 4. This is the size of the regression line. Then label equal f regression line, where R coefficient of correlation is labeled from R value. This is the created variable above, where R value is rounded to 2 decimal places. Run. Message error. Got an unexpected keyword argument label. This is not written like this. Let us go and correct it. Label. Add error. Run. This is a regression line. Let us reduce the size of the regression line. Let us make it 2. The size reduced. This figure is not complete. There are a lot of elements still lacking. Let us add annotations for percentages. plt.text. Open and close the bracket. X square bracket minus 1 plus 1. In the case of plotting, x square bracket minus 1 would represent the x coordinate of the last data point. By adding 1 to it, you are positioning the annotation 1 unit to the right of the last data point, ensuring the text does not overlap with the plot itself. Then add another argument, target underscore value plus 1, comma, then rename above underscore target as above target. Rounded to 1 decimal place. In the percentage, comma, add the color equal green and add another argument for font size equal 10.5. Run. Above target 92.9%. Copy the same command and do the same for below target. Below target. And this is below. Target value minus 1. Run. Okay, this is the target line, 7.1%. Below the target line, 92.9% above the target line. These percentages seem to be far from the target line. Let us make them closer to target line. Target value plus 1, let's say plus 0.3. Run. You can see it is now closer the target line, 92.9%. Then below, we also make it closer. Let's say minus 5. No, minus 0.5 from minus 1. This is okay. Let us change the font size for percentages from 20.5 to 11. Run. Okay. Below target is touching the line here. Let us make it not touching the line. This is 0.5. Let us make it minus 0.6. Fine. Let us add the title. Bring your library multi-plotlib for plotting the title, plot dot title let's say median number of children versus parents' age at first cohabitation. Run. This is the title. Let us increase the font size of the title. Okay. We can also add the X label. This is age at first cohabitation. plot.x label age at first cohabitation. Run. We can also increase the font size. We make it 12. Okay. Y label. Number of living children. Let us label it as the number of children. plot.y label number of children or number of living children. The font size, make it 12. Run. Fine. What else is lacking? Legend is lacking. Let us add it. plot.legend. We can also add the grid lines. Plot.grid. This is for both x-axis and y-axis. Let us make it for only y-axis. Axis equal y. Run. Sorry, this is the axis. Okay. Let us change these grids to dashes. Add another argument here. Line style equal dashes. Run. We can also add the size of the grids to make them more seen. Alpha equal 0.7. 0.7, 0.9. Okay, this is fine. Save. So let us deactivate the random seed and we see. Now, as we deactivate the seed value, the coefficient of correlation will keep on changing. Run and see. 0.09, run again, minus 0.13, run again, 0.23. So it keeps on changing because there is no seed value. Activate it now. It is 42. The seed value is minus 0.04. Run again. It doesn't change. But there is still a problem. As the seed value is set to be 42, the correlation coefficient is minus 0.04, different from the coefficient of correlation computed before, which was minus 0.25. Now, which seed value should I set so that the coefficient of correlation computed here, minus 0.25, meets with the coefficient of correlation at my figure? Let us change the seed value and see. Make it 60 or 70. Run. It is minus 0.04. Change it. We need minus 0.25. Change it again. 53. 2.5. No, sorry. 0.04. No, we need minus 0.25. Let's say 84. Run. 87. Run. Coefficient of correlation is minus 0.25. This is fine. So if you run it again, it doesn't change. Here, what does it imply? With the seed value of 87, the coefficient of correlation is minus 0.25, which is equivalent to the coefficient of correlation computed before establishing the algorithm. Then, with the seed value of 87, the above target is 85.7, below target is 14.3. In this case, as age at first cohabitation increases, the number of children tend to decrease, though the relationship is weak. So, age at first cohabitation slightly affects the number of children. Since only 14% of children are below the target, this raises a significant policy concern. The goal is to raise the number of children by 90%, counted below the target value, within 4 years, 5 years, etc., depending on the set time frame to measure this kind of indicator. If you enjoyed this content, please don't forget to like, share, and subscribe. More exciting contents are on the way. See you in the next session.